Hello. So now we are solving the first question from the Pure Mathematics 3, and this is May-June 2019 paper and the first variant. So let's get started. The question states that using this trapezium rule and with three intervals, we need to estimate the value of the given integral, this one. Okay. So let's get started. Here in this case, as we can see, the lower limit of the integral is, let's call them a, is 0. The upper limit is 3. And the number of intervals, in this case it is 3, because we are asked to use 3 intervals. So n equals 3. And we also need to find the difference between the intervals, which is denoted by h here, and it is defined as b minus a over n. So this will give us the difference between the intervals. So b minus a is 3 and a is 0 and n is 3. This will give us 3 over 3, which equals to 1. Perfect. So let me also write down the formula, which you can easily find from the textbooks. So 1 over 2 times h times the initial value of the function, like the value of the function at the lower limit, plus the value of the function at the upper limit, which is y3, plus 2 times the value of the function in the mid intervals. In this case it is y1 plus y2. Okay, so we have to simply use this formula, but we need to find out y0, y1, y2 and y3. So let me make a quick table here to list all these values. Okay, so here we can say x, and then this is the value of y, and y basically here is the function, so which is 2 to the power x minus 4. Okay, and then we have x starts from 0, 1 and 2 and 3. So the lower limit is 0, then the difference between the interval is 1, so the next value should be 1 and 2 and 3, and we have to evaluate the value of y at these points of x. So when x is 0, so as you can see, if you simply insert the value of x into this expression, so 2 to the power 0 would be 1 minus 4 is minus 3, but since we have the modulus, that will make this minus 3 to positive 3. And similarly, when x equals 1, this is going to give us 2 minus 4, which is minus 2, and then the modulus will make it positive, so this is going to be 2. And when x is 2, then 2 to the power 4 is 4, 4 minus 4 is 0, and when x equals 3, the value we will get 2 to the power 3. This will give us 8 minus 4 equals 4. Okay, now we have all the values. Now we simply have to insert these values into the expression. A, which is equals to the value of the integral, which equals 0 to 3, the modulus of 2 to the power x minus 4 and dx, and that is equals to 1 over 2. In this case, height equals 1, or h equals 1, times y0, which is, by the way, this is y0, this is y1, y2 and y3. Okay, so y0 is 3 plus y3, which is 4, plus 2 times y1 and y2, so 2 plus 0. Okay, now we simply have to evaluate this expression. 1 over 2 times 3 plus 4 is 7, plus 2 times 2 is 4, so this will give us 11 over 2, and which is also equals to 5.5, and that is our answer. So the second question says, showing all necessary working, solve the equation ln 2x minus 3 equals 2 ln x minus ln x minus 1, and we are required to give the answer correct to 2 decimal places. Okay, so let's get started. We have this expression ln 2x minus 3 equals 2 ln x minus ln x minus 1. The first step we should do is to make the coefficient of all the terms equals to 1. So that means here, which this 2, we need to make this coefficient. We can use the power of the property of the log, so this will become ln x squared. So we can take 2 as the as the power of the x. So this 2 will become the exponent. So ln 2x minus 3 equals ln x squared minus ln x minus 1. And now we can simply use the property of log. For example, on the right hand side we can see ln a minus ln b, which is equals ln a over b. So this will give us ln x squared over x minus 1. And on the right hand side we have only one term, so we don't need to simplify. And since we have log ln both sides, so we can somehow cancel them. So this will give us 2x minus 3 equals x squared over x minus 1. Okay, now we have to simplify this expression. So first thing we should do is to do the crisscross or the cross multiplication. That means I will multiply this expression 2x minus 3 with x minus 1 and or wait a second. So let me also write here like 2x minus 3 over 1, so we can do the cross multiplication. So this will give us 2x minus 3 times x minus 1 equals x squared times 1, which is equals to x squared. And now we have to simplify this expression. So 2x minus 3 times x minus 1 would be 2x squared. So we will multiply the first term with the first term and we can expand this. So 2x minus 3x plus 3 equals x squared. Now let me also move this x squared on the right hand side to the left hand side. So 2x squared minus x squared would be x squared minus 5x plus 3 equals 0. So basically this is a quadratic equation, and we can solve this expression. So we can either use, since we are allowed to use your calculator, and most of the calculator can solve it, so I would recommend you to simply use your calculator to solve this quadratic equation, which is also going to save time. So basically, once you solve, you will get x equals 4.30 or x equals 0.70. So of course, the quadratic equation gives us two answers. But before you report your final answer, you have to check, because especially if the log is involved, some of the answer might not work. So basically we have 4.3 and 0.70. So let's see to the original expression. So as you can see, if you use this 4x equals 0.70 into this expression, so 0.70 minus 1 will be 0 minus 0.3, and log is not defined for a negative number or also for 0. So log is not defined for 0 or less than 0. That means this answer is out of the range. So we have to explicitly mention this, and we have to report the final answer is, so x equals 4.30 is our final answer, and this is out of range. Okay, so you must report only one answer, otherwise you might be penalized. Okay, so now we are going to solve question number 3, which states as find the gradient of the curve x cube plus 3xy squared minus y cube equals 1, and at the point with coordinates 1 and 3. Okay, so we have this expression x cube plus 3xy squared minus y cube equals 1, and you should have realized this expression is implicit equation. That means x and y, they are intertwined, and it's not easy or sometimes possible to separate them, like separate x from y. So but we don't need to worry, we can still find the derivative. So what we can do, we can apply the differential operator both sides. So let's do d over dx of x cube plus 3xy squared minus y cube equals d over dx of 1. Okay, so now we can find the derivative both sides. So derivative of x cube is going to be 3x squared times dx over dx, which is 1, plus, so now we have to also differentiate 3xy squared. So let me also do one more step. So 3, we can take 3 is constant as outside, so d over dx x y squared minus d over dx y cube equals d over dx of 1. So 1 is a constant, so the derivative of 1 with respect to x is going to be 0. Okay, so now we have 3x squared plus 3 times, we have to differentiate xy squared, so we can use the product rule. So the first function as it is, x times the derivative of the second function, which is going to be 2y and dy over dx, plus y squared, which is the second function, times the derivative of the first function, which is dx over dx equals to 1, minus, so the derivative of y cube equals 3y squared and dy over dx equals 0. Okay, since we are asked to find dy over dx, we have to combine the term which has this dy over dx term. Okay, but let me first expand this expression. 3x squared plus 3 actually is going to be 3 times 2, 6. Yeah. So 6xy dy over dx plus 3y squared minus 3y squared dy over dx equals 0. Okay, so now let's collect the dy over dx term together. So 6xy minus 3y squared, basically we can collect these two terms, this term and this term. Okay, and that equals to, we can take the rest of the term on the right hand side, so this will become minus 3x squared minus 3y squared. Okay, so this means dy over dx equals minus 3x squared minus 3y squared over 6xy minus 3y squared. So at this step you can take 3 common from both numerator and denominator, or you don't actually have to do that since we are asked to find the derivative at the point. So at 1, 3, so dy over dx at 1 and 3, we can simply insert the value of x as 1 and the value of y as 3 and simplify this expression. So once we put these values, we're going to get the answer as 10 over 3. So you can simply put the value and then find this answer. So 10 over 3 is the answer, or you can also write as 3.33, but 10 over 3 would also work. Okay, now we are at question number 4. By first expressing the equation cotangent theta minus cotangent theta plus 45 degrees equals 3 as a quadratic equation in tan theta, solve the equation for theta which is between 0 and 180 degrees. Okay, so let me write down the equation. So cot theta minus cot theta plus 45 degrees equals 3. Sorry. Okay, first thing we should realize is that it's not actually quite easy to work with cotangent or also cosecant and secant theta, like the reciprocal functions. So what we should do is we can simply convert this or change this into tangent theta. So as we know, cot theta equals 1 over tan theta. So we can simply write here cotangent theta is going to be 1 over tan theta minus 1 over tan theta plus 45 equals 3. Okay, now we have to use the compound angle formula, so which is tan A plus B equals tan A plus tan B over 1 minus tan A times tan B. And in this case, the A is theta and B equals 45. Okay, so let's simply use the formula. So 1 over tangent theta minus, okay, and since tangent theta plus 45 is in the denominator, we have to flip the values, the numerator and denominator. So I'm going to write here 1 minus tangent A times tangent B, but tangent A is theta and tangent B is 45, so B is 45, So tan A plus tan B, so tan theta plus tan 45, okay, equals 3. So we know like tangent 45 is equals 1 because tangent 45 is sine 45 and cos 45, so it will give you the value as 1. So 1 over tangent theta minus 1 minus tan theta, and tan theta plus 1, because tangent 45 equals 1. Okay, so now we have this expression. We have to simplify this further. At this point, you have to understand that to simplify this kind of expression, we have to get rid of the denominator, because with the denominator it's not quite easy for us to solve the equation. So let's try to get rid of the denominator, and the way we're going to do is to we're going to multiply the whole expression by the LCM of the values in the denominator, which is tangent theta times tangent theta plus 1. That means I'm going to multiply the whole equation with tangent theta times tangent theta plus 1. And please don't forget this brackets, because this is important, this term. Okay, that means we have 3 terms in this equation: the term 1, term 2, and term 3. We are going to multiply each term with this LCM. Okay, so let me multiply the first term, which is 1 over tan theta, here 1 over tangent theta. Let me multiply this with the tangent theta times tangent theta plus 1, sorry, minus 1 minus tangent theta over tangent theta plus 1. I'm going to multiply this with tangent theta times tangent theta plus 1 equals 3. And I'm also going to multiply this term with the tangent theta times tangent theta plus 1. Okay, as you can see, we can cancel this tangent theta with tangent theta, and we are left with tangent theta plus 1 minus, so in the second term we can cancel this with this value, and that will give us 1 minus tangent theta times tangent theta equals 3 times, let me multiply these two guys. Tangent theta times tangent theta is going to give us tangent square theta plus tangent theta. Okay, now we have to simplify this expression further. So let me just write here tangent theta plus 1 minus tangent theta plus tangent square theta. So I basically multiplied these two terms, equals 3 tan square theta plus 3 tan theta. Okay, I think now we have to collect the like terms together. So this is going to give us, so let me move this tangent square theta on the right hand side. So this will give us 2 tangent square theta, and also we can cancel this with this, so plus 3 tangent theta and minus 1. So what I did, I just collected all the terms on one side. Okay, now actually we can realize that this is kind of quadratic equation in tangent theta. So this is 2 tan. So like for example, if I just simply replace tan theta with t, so suppose tan theta equals t, this will give us 2t squared plus 3t minus 1 equals 0, and we have to simplify this or solve this equation. Again, I would recommend you to use your calculator. So once you use your calculator, you will find the answer. So t equals, or t, which is also equals to tangent theta, equals to, so the value you will get is minus 1.78, and sorry, or tangent theta equals 0.28. Okay, now we can find the value of theta. So tangent theta equals tan inverse of minus 1.78, or theta equals tan inverse of 0.28. Okay, so this will give us minus 60.67 degrees, and this will give us theta equals 15.7 degrees. But before you report your answer again, you have to be careful. So we have to make sure that the values are not out of the range. And since we are given that the theta ranges from 0 to 180 degrees, that means we can simply take this and this thing as an answer. So this is our answer. But minus 60.67 degrees is not in the range, right? But we also know that the second value of the tangent theta can be achieved by simply adding 180 degrees. So let's see if we get the answer in the range if we add 180 degrees, which we do when we find the theta from tan inverse. Okay, so let's simply add 180 degrees to this value. So 180 degree minus 60.67 degrees. Okay, so if you simplify, if you just use your calculator, you're gonna get 119.3 degrees, and this is again in the range, which is from 0 to 180 degrees. So we have to also report this answer. So we're gonna get two answers. The first answer is this one. Second answer is this one. By the way, we can also add 180 degrees to this one because we always do. But then if you add 180 degrees to 15.7, the answer you will get is going to be more than 180 degrees, which is again out of the range. So these two are the answers. Okay, so now we have question number 5, where we are asked to differentiate 1 over sine square theta with respect to theta. So we have 1 over sine square theta. We can of course write this expression as sine theta and to the power minus 2. Okay, so we can differentiate this expression d over d theta, d over d theta. Alright, so this derivative, we can simply use the power rule first. So minus 2, the power becomes the coefficient, and sine theta, and minus 2 minus 1. We have to subtract 1 from the power, and then we also have to multiply with the innermost function. So in this case, we have to multiply with d over d theta of sine theta. So basically we're gonna get minus sine and minus 3 theta, and the derivative of sine theta is cos theta. Or I can also write this as minus 2 cos theta over sine cube theta, and which is the derivative of 1 over sine theta. Right. Okay, and now we are going to solve the second part of question number 5. Here we are given a differential equation, and we need to solve this equation, and we need to solve this equation for x. Okay, so let me write this equation. X tan theta and dx over d theta plus cosecant square theta equals 0. Okay, to solve this expression, we have to isolate theta and x terms. So in this case, let me just simply write here. So let me first move the second term to the right hand side. So x tan theta dx over d theta equals minus cosecant squared theta. Yeah. And now, since I want to collect the same variable on one side, so it's going to be x dx, and here we can move the tan theta and d theta on the right hand side. So minus cosecant squared theta over tangent theta and times d theta. Okay, so now we have nicely collected the x terms on the left hand side and theta terms on the right hand side. So this is the very crucial step in solving the differential equation. Okay, now to solve this expression we simply have to take the integral both sides. And the left hand side, the integral is quite easy, x squared over 2 is a simple power rule. And on the right hand side we have to see how we are going to integrate this term, which is a bit complicated apparently. Here we have minus cosecant squared theta and tan theta, but in this kind of situation, it's a good idea to convert it into the basic trigonometric function. So for example, cosecant is 1 over sine and tangent is sine over cos. So let me simply write these values, so we might be able to see some pattern here. So 1 over cosecant squared is 1 over sine squared, so let me write here 1 over sine squared theta, and tangent theta is sine over cos, but since the tangent is in the denominator, we can write the reciprocal. So it's going to be cos theta over sine theta and d theta. So which can be written as minus cos theta over sine cubed theta and d theta. Alright, so at this point you should have realized that this expression on the right hand side, this is what we actually have solved in part 1. So this expression is equals to 1 over 2 times 1 over sine squared theta. So let me write this here, 1 over 2 times sine, 1 over 2 times 1 over sine squared theta, and plus c, which is the constant of integration. So you have to be mindful at this point that whenever you have like multi-parts equation, so most of the time you are supposed to use the information from the first part into the next part. Okay. Alright, so now we have to solve this equation, and then we are also given the initial condition, which says that when x equals 4, then theta equals pi over 6. So we can use this information to solve this constant of integration, which is c. So x is 4, that means x squared, which is going to be 16 over 2 equals 1 over 2 times 1 over sine squared pi over 6 plus 6. Okay, so 16 over 2 is equals to 8, and 1 over 2 times sine pi over 6 is 1 over 2. So sine squared pi over 6 is going to be 1 over 4, and since this is in the denominator, this will become 4 plus c. Okay, then we can simplify. We get 8 equals 2 plus c, and this will give us c as 6. So now let's replace c with 6, and we have x squared over 2 equals 1 over 2 1 over sine squared theta plus 6. So this is actually the solution, but of course we can simplify it further, or we have to simplify it further. We need to find we need to find the answer in terms of x, not x squared. So let me just multiply the whole expression with 2. We're going to get x squared equals 1 over sine squared theta plus 6 plus 12, and 1 over sine squared theta equals cosecant squared theta. So let me write this as cosecant squared theta plus 12 equals x squared, and now we can simply take the square root both sides. So we're gonna get x equals cosecant squared theta plus 12, and that is what we are asked to show.